we are going to explain about a project titled Enabling the Reuse of Software Development Assets Through a Taxonomy for User Stories. Coming to the introduction part, enabling the reuse of software development assets through a taxonomy for user stories represents a significant step towards enhancing the efficiency and effectiveness of software development processes. By providing a systematic classification and organization of user stories, this approach enables the seamless reuse of development assets across projects, fostering knowledge sharing, consistency, and collaboration among development teams. Ultimately, the taxonomy empowers software development organizations to optimize their resources, reduce redundancies, and deliver high-quality software products in a more timely and cost-effective manner. By establishing such a taxonomy, software development teams can streamline the process of identifying and retrieving relevant user stories from a repository of assets, thus avoiding duplicate work and facilitating knowledge sharing. So now coming to the objective part for this project, enabling the reuse of software development assets through a taxonomy for user stories is to optimize software development processes by establishing a structured and unified approach to classifying and organizing user stories. By enabling the reuse of development assets, promoting collaboration, and fostering knowledge sharing, the taxonomy empowers software development organizations to operate more efficiently, deliver high-quality products, and continuously improve their development practices. By enabling cross-project asset reuse, development teams can leverage existing user stories from a repository of assets along with the associated knowledge and experiences to inform and guide new projects. This not only saves time and effort but also promotes consistency in software development outcomes and enhances the overall quality of delivered products. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first, upload user stories dataset. The first step in the process involves uploading a dataset of user stories. User stories are essential artifacts in agile software development, describing end-user requirement in a concise and user-centric manner. The dataset should contain a collection of user stories from various projects, representing a diverse range of functionalities and domain-specific features. Second, identification and extraction terms. Once the user stories dataset is uploaded, the system identifies and extracts relevant terms and keywords from each user story. These terms play a critical role in categorizing and classifying the user stories accurately. The extraction process helps in capturing the essence of each user story and preparing the data for further analysis. Third, construct taxonomy vector. With the extracted terms, the system proceeds to construct a taxonomy vector for each user story. The taxonomy vector represents the user's story characteristics based on its functionalities, domain, complexity, or other relevant attributes. It serves as a structured representation that will be utilized and used to categorize and organize the user stories. Fourth, build random forest machine learning model. To enable automated classification of user stories, a random forest machine learning model is built. Random forest is an ensemble learning algorithm that combines multiple decision trees to improve accuracy and reduce overfitting. The model is trained on the dataset of user stories with their corresponding taxonomy vectors. Fifth, enter test input and classify user stories. Once the random forest model is trained, the system is ready to accept test inputs in the form of new user stories. The user stories are entered into the system, and the model uses the previously constructed taxonomy vector to classify and categorize each user story. The classification process assigns each user story to specific categories based on its attributes, functionalities, or domain. 6. Exit. After classifying the user story, the process concludes and the system exits. The output of the classification is available for further analysis and decision making in software development projects. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as user stories dataset. In this we have .java files, and in these files we are containing some dataset. This user stories is the Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload user stories dataset button and upload entire folder which contains all software code. So here I am selecting user stories dataset and now click on select folder button to load all code for getting the output. Here on this screen dataset loaded, and now click on identification and extraction terms button to read and extract terms from all program scope. So here on this screen, application start reading all data programs, all user stories, and then extract terms from all programs, and then we will get the screen as on the screen as term extracted process completed. And now click on OK button, and now click on construct taxonomy vector button to convert all user stories into numeric vector, and then we will get the output. So here on this screen, vector is generated from all user stories. And now click on build random forest machine learning model button to build machine learning model. So here we can see dataset contains 213 user stories of software programs, and then application dividing 213 user stories to train and test, where it is using 170 user stories to train machine learning model, and then applying train model on 43 test user stories to calculate prediction accuracy. And here random forest machine learning algorithm got 97% accuracy, correct prediction accuracy out of 100. Now machine learning model is ready, and now click on enter test input and classify user stories button to allow new user to enter some test story, and then machine learning model will automatically search matching user story from trained model shown as output to user, and this output user can reuse in his project. So now on this screen, here I have to enter writing recursive subtree matches. Writing recursive subtree matches. So here the user entered writing recursive subtree matches, which means I want software component which contains logic for recursive subtree matching, and then machine learning trained model will predict or classify matching user story for getting the output. So now click on OK button over here, and so over here the screen opens, application saying above program is contains logic for new user, and then user can reuse above code in a software. Now closing this screen, so now on this screen, application displaying program name from dataset folder which contains test user story. If we give any story which is not available in machine learning trained model, then we'll get the output. So now again I will click on enter test input and classify user stories. So I have to enter the text over here, suppose cup of tea. So now I entered user story as cup of tea, which is not available in machine learning trained model, so we will get the output. And now click on OK button. So here it shows that sorry, unable to classify. Similarly, machine learning trained on dataset folder user trained stories, so it will give you automatically classification request if you are given story found in trained model. Now click on exit button to execute with this graphical user interface. So now coming back to the conclusion part, as software development continues to evolve, the adoption of such innovative approaches to asset reuse and knowledge management becomes increasingly essential. The taxonomy for user stories serves as a valuable tool in supporting the growth and success of software development organizations, positioning them to meet the ever-challenging demands of the industry while maintaining a competitive edge. Ultimately, this approach paves the way for more efficient, effective, and innovative software development practices in the pursuit of delivering cutting-edge solutions to end users and stakeholders. Moreover, the taxonomy fosters collaboration and communication among development teams by providing a standardized language and structure for discussing and sharing user stories. This shared understanding enhances team synergy, minimizes miscommunications, and allows for efficient coordination, particularly in large and distributed development environments.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.